Hey YouTube, it's JP Dillon. Today we're looking at a early 1960s Sears Silvertone 10 transistor AM radio. This was a nice pickup find at an estate sale. The top, this here is actual cowhide, which they print on the bottom. Rooftop and bottom screws for battery service. I have no idea about the condition of this. It was a cheap find. It's incredibly heavy. Probably not honcoidal type stuff. So we're going to open it up and take a look inside and see what we're up against here and see if we can't get this thing working. So we're going to start by removing the top and bottom screws so we can take the back cover off. Alright, let's change camera angles here so we can get a better view as to what's going on. Been seeing a lot more transistor radios show up lately at estate and yard sales, and surprisingly people aren't trying to take your spleen for them. They're actually very reasonably priced. I'm getting to the point in my collection where I just want to keep the really nice ones, or ones that could be nice, and the rest of them can find new homes. Alright, so we got the top and bottom screws off. Let's see if it's possible to get this up and off. You can see that the AC terminal down here at the bottom is kind of stuck up, so it may have been dropped or something. It's trying to come loose. Let's see if we can do a little tiny bit of prying action here at the corner. There we go. Starting to give there. And there she is. Well, I see already that we have a loose corroded battery terminal. So there's that. Speaker made by Foster. These E-bar sand capacitors, I've seen these in a lot of mid-60s equipment, so maybe that's more along the lines of when this is. Pretty good looking on the inside, and the fact that it's got an actual tuner string, a dial string, is it's impressive. It's working there. A little on the stiff side, but alright. And let's see what's going on with this. I guess this is just supposed to fit into the cover because it's just literally loose here, so it's supposed to fit into this notch here on the side. And somebody just buggered that. Since this is the terminal without the wire, I'm going to assume that that's where this attached to. And let's see how many batteries and what type of batteries. Looks like double A's. And we have another corroded wire here. And then I assume there was supposed to be something here. Looks like it broke off. We peer down in here. This terminal down here where my thumb is was supposed to have two wings on it. So that's definitely not, that's not possible there. I'm sure I can create something. But that may have been why it was bricked. It was because the battery terminals were eaten away. So if we look inside of here, we see that that is the example of what the other one that's crusty rusty away there is supposed to be. And then they series all these batteries with this wire. And then let's see, you got the red one which leaves here and goes up to the chassis. So definitely got some work cut out for us, but we should be able to create a battery terminal of some kind that will work. I may have a spring or something that I can solder to that terminal pad down there once we clean this up, because that's pretty ugly. But yeah, a lot of fun ahead on this one. let me get some tools. I'm not going to have enough room to put the Dremel in front of the camera and stuff so you'll be able to see it, but I'm going to try to clean up this terminal that's corroded here, and then see if I can find a spring that we can use to attach to that terminal so that we at least have battery conductivity. Okay, so we got our terminals cleaned up, and I got a little springy dingy that I harvested from a dead battery holder. But the problem is that the solder is not sticking to the metal, which is largely tin, I assume. And so we need to find a way to attach this. So I'm going to do something very unorthodox and a little bit dangerous. And so what I'm going to do is take this big fat capacitor, charge it up, and we're going to spot weld this thing. And basically I'm going to attach the ground to the terminal that's there, and then attach a clip lead to that guy, and then touch the two together with the charged capacitor, and hopefully they will weld themselves to the terminal. And like I said, unorthodox, but there's nothing else hooked up to this, so I don't think there'll be any injury risk to the radio. But short of replacing the entire battery holder, this is our last effort in trying to get this thing sorted. So I suppose you're wondering now, how am I going to do that? So you always wondered what the little bridge rectifier on the dim bulb was for. This is one of these projects. So we're going to charge this capacitor up through the light bulb so that I don't overcharge it. And we're going to monitor the voltage across it. And when it becomes 100 volts, which is what the rated voltage is on this, it'll be charged, and then we can attach the appropriate means and get this thing welded up. So let me attach my meter, and then we can watch it charge itself up. Alright, so I've got it hooked up to my Variac, and we're just going to slowly increase the voltage here. That's probably good enough. There's 98 volts on that capacitor. And we're starting to bleed down because of the loss through the rectifier there. Alright. So now, let's attach things. Alright, everything should be good here. I'm going to stress this, do not try this at home. We're going to see what happens here. And I don't think I have enough room to put that in there. It's going to make a big old scary spark. Assuming I can get the insulator away from the area enough. This is very dangerous, and I do not recommend you do it. There we go. She's welded. All right. You can see down in there that we welded it right to the terminal. And so now what I can do is bend and move that around and clean up the soot, of course. And then we should have a usable battery terminal. Alright, so with everything back in there and cleaned up, we can see that those two 1.5 volt batteries come out to 3.2721 volts. So my contact repair worked. So what I'm going to do is solder the remainder of wires back to the terminals after I clean those up. Put another two AA batteries in it so we have a 6 volt supply, and then turn it on and see what happens. And now with the wires reattached, the white one there and the black one underneath the clip there, the radio should be getting 6.5 volts. So now that we know that, let's turn it on and see what happens. Alright, let's got a hiss, that's good. That's real good. There's KFI. That's 610 down in Tijuana. 600.
Everybody agrees to go by. That's where people are having issues.
That's 1070. It's KNX. That's 1090. Great selectivity on that. Look at that, 1070, which is 100 plus miles away. And there's 1090, which is in San Diego. Whew, that's good.
So there are comments.
Villainous, loathsome figure.
It's a hot little radio. Something's supposed to be there, but it's dead air right now.
Morning show. Poppy Harlow, Caitlin.
This thing works great. So I probably could go through this and replace a bunch of capacitors, but I don't think it would improve the performance any. This thing's working amazingly well. So I guess what we do is we put it back together and just enjoy it. I was really lucky that we were able to get the battery compartment fixed. So it should slide together kind of like this. I'm going to get the little terminal assembly into the cover as best as possible. There we go. And then that all pushes back together. Yeah, this thing just didn't want to go in proper. There we go. Then it's just a matter of putting the screws back in. I do need to clean the case up a little bit. Don't know if I have anything here that wouldn't hurt the leather. I think I may just some mild soap and water or something like that for the leather. Or I'll just leave it be and until I have leather cleaner. Getting them screws back in ain't easy though, I'll tell you that. You get something that's a little more wieldable. Yeah, this is going to want to fight me, of course. I'll probably end up using this quite a bit because it's a really hot performer. Definitely a keeper for me. Let me get the top screw back in. And there she is. All nice and back together.
Just say what the facts are. Google it. Everybody at home.
This thing works great, man. Let's see if we can't clean this up just a little bit here. Well, I went at it with a little bit of kind of Goo Gone oil cleaner, but that didn't really change anything. Just got a little bit of surface dirt off, so I may investigate how to clean that up a little bit better, or may just leave the patina alone, because otherwise it works just fine. Sounds really good. It's incredibly sensitive. So I still was not able to find any kind of model number information on this. So maybe it's time to query the internet a little bit and see if we can find it. And this is why I love the internet. This is on radiomuseum.com. It's a 1966, and it's model 6214, which was catalog number 132-621401. You can look up what the prefix of that is, that 132, and we can find out who made it. It was probably Warwick, but we'll find out. I downloaded the schematic, so we can take a look at the simplicity of that in just a moment. But let's see if we can figure out who the manufacturer was. And if you go to vintagemachinery.org/craftsman/manufacturers.aspx, this is the Sears manufacturer list. And so if we scroll down here, 132 is, they claim to be Arvin/Norbert Sparks. Come on, focus. Radios and maybe small appliances. So very likely this was an Arvin product. Very cool. So 1966. I figured with those capacitors it'd be mid-60s. There it is there. It's just like ours. Now let's see what the schematic looks like. So here it is. It's basically got a tuned RF front end, 2 IF stages, and then you got your audio driver stage with an emitter follower, a driver, and an output through a transformer, and then an output transformer. That's pretty high quality stuff back in the day. Really nice piece of equipment I got. Definitely a keeper. So I hope you guys enjoyed this little quick video and some very creative work on repairing those battery terminals. Again, that's not something I would recommend anybody do, because you have to have experience with high voltage and know how not to injure yourself and injure the equipment that you're working on. Because one mistake, and that would have been 100 volts DC, which would not only hurt, but could stop your heart. So use your head, and if you don't know what you're doing, leave it to somebody who does. Anyways, thanks for watching, guys. More stuff to come.